Hello everyone. Today we are going to discuss another concept of the chapter 1, that is electric field. Let's discuss this in terms of the concepts which you already know. Suppose if you know the cost of 10 pencils, can you find the cost of one pencil? And if you know the cost of one pencil, you can find the cost of any number of pencils, right? Same way, if we know a given pair of charges, we can tell about the force acting between the two charges if we know the separation between them. But what will be the force exerted by a particular charge to any charge placed around it at some distance? To find that, we need to apply this concept of unitary method of mathematics, and that is applicable in the form of electric field over here. So, let's start this. Electric field is simply the force acting on unit charge placed around the source charge. I'll tell you what the source charge is. First of all, it is the force experienced by a unit charge placed around a source charge. We can compare it with the case of gravitation again. Now, if we have this earth, right, and we know that this exerts a gravitational force on every object which is placed here, right? So, how do we know that it exerts a force on any object placed over here? We know that if we place any object here, this object will fall towards it, right? But how much force will it exert on every object? To know that, we must know that how much force it exerts on unit mass. So, that force is, if we know this, that we are just relating it with the gravitational force, this we know that this is G m into m upon r square, where small m is the mass of the object which is falling down, capital M is the mass of the earth. So, this is the force between these two masses. First is the earth, which we are considering here as the source of gravitational force, though small mass will also exert a force on the earth, equal and opposite, right? So, here if I want to know the rate of the force exerted by earth on any object, I'll find it by dividing this force by small m. We will get the rate. So, we can say that this F per unit mass is Gm upon r square. This is the rate of force per unit mass. This is for understanding only, right? So, if I know this, I can find the force on any mass, and this we actually know is the intensity of gravitational field. If you remember, this is intensity of gravitational field, which is actually small g. More important here is this intensity of gravitational field. So this is giving you the rate. Now if I want to find the force on any mass, I can multiply this force per unit mass by the given mass to get the force on that particular mass. Suppose I want to find force, gravitational force on 5 kg mass, right? So if I know this, this force will be intensity into small m, that means G m upon r square into 5. So this is 5 times the intensity. Similarly, and second thing is, now if this object is falling towards earth, then we know that there is a gravitational force which is exerted by the earth on this mass. Similarly, if we have a charge, this was just for understanding, I'll rub it later. If I have a source charge, which you can compare with the earth, which we had taken in the case of the gravitational force. So if I have a source charge, I want to know that how much is the electric force exerted by this charge on any charge which is placed around it. What will I do? I'll place that charge around it. If it experiences any attractive or repulsive force, that means it is exerting some force on this. So the force experienced by this charge tells us that there is existence of the force around it. If it doesn't experience anything, there is nothing, right? So for this, if this is positive charge, then this will experience a repulsive force. If this is a negative charge, it will experience an attractive force, right? So here, this can be called as test charge, and this can be called as source charge, right? And this separation, if we are marking this separation as R, right? And if we consider that this source charge is placed at point O, right? And this test charge is placed at point P. Then the vector along this direction is R vector, and this direction of R vector is given by R cap vector, which is a unit vector along this direction, right? So that means this is the charge whose force we are testing around it. This is the test charge which is helping us in testing the force due to this. So we have to find the rate. If on Q charge the force is the Coulomb force, is if I am writing this in vector form, I will mention it like this. I will write the magnitude of force and the direction. I will first check what will be the direction. This is a positive charge. If this is the positive test charge and this is positive source charge, what will be the direction of the force? This will be the direction of force. That means this will be along R cap, right? And what will be the magnitude? This will be 1 by 4 pi epsilon naught first charge, second charge upon separation square into R cap. right? And if I want to know the rate, that means if I divide this force by Q, this is actually force per unit charge, and this we are defining as electric field. So what is electric field? It is a force acting per unit charge on a unit test charge which is placed around a source charge plus Q. So from here, if I mark this as equation 1, this as equation 2, so from 1 and 2, what will I get? I'll get F upon Q, that is the electric field. This from here, if I take this in the denominator, I'll get 1 by 4 pi epsilon naught Q upon R square into R cap. So what will be the direction of electric field? The direction of the electric field will be same as the direction of electric force, which is actually the direction of R cap, right? So we can mention it over here that the direction of electric field is same as direction of force. Right? This is very important point which you will use in the numericals. So here you can mention that this is a concept of 11th. So now if you know this electric field, you can find the force on any charge which is placed there, right, around the source charge. So we get another formula for force from the definition of electric field, this, right? So if I know this rate, I can multiply by the charge which is placed around the source charge to get the force experienced by any charge placed in the region around the source charge. So electric field in simple terms can also be defined as, it is the region around the source charge where the effect of electrostatic force can be experienced, right? But that's a layman language definition. This is the technical definition. It is the force experienced by a unit charge placed around a source charge. So we want that our source charge must remain undisturbed. For this, one condition is applied, that our test charge must be very small. So we are writing some important points. You can say important note. First, test charge must be infinitesimally small to avoid the disturbance to the source charge. So sometimes we write this in the form of this limit also. We can write that electric field is equal to limit q tends to 0, very very small, such that it can be considered tends to 0, not 0. Okay, limit q tends to 0, and this is F vector upon q, right? So this is how we can write the electric field. Second important point is that for positive test charge, for positive source charge, the electric field is away from the source charge, and in case this source charge would have been negative, the electric field will be towards the negative source charge, because there will be attractive force. So for positive source charge, electric field points away, because by convention we take test charge as positive only. By convention, right? And then for a negative source charge, electric field points towards the source charge. We can show it here. If we have a negative source charge and then we have this obviously positive test charge, so what will be the force? The force will be attractive. So the direction of electric field will be this way, right? So in other form, if I want to draw the NCERT diagram, if we have a positive test charge, then the electric field points away, and if I have minus test charge, then the electric field points towards. Right? And that means it gives us the rate at which the electric force is exerted on any charge placed around the source charge. Then we can mention that electric field is also a vector quantity as electric force. Its direction is same as the direction of electric force. Moreover, electric field is spherically symmetrical. We can write this formula once again for our reference. This is the formula for the electric field. This is our equation 3. Electric field is spherically symmetric. Spherically symmetric means what does that mean? At same distance, the value of electric field is same around that point source charge. So that we know the formula, this is sorry, 1 by 4 pi epsilon naught q upon r square. If I am writing in vector form, this will be r cap, right? So it is inversely proportional to the square of the distance of the point where we are finding the electric field. So it is spherically symmetric. So if I have a point charge here, point source charge here, so at every point which is at the same distance from this point Q, the electric field will be same because it is proportional to 1 by r square. So this was all about the basic concept of electric field. I hope you understood. That's all for now. Have a nice day.